students, in the previous part we have studied different types of chemical reactions, that is combination reaction, decomposition reaction and their types. Now there is another type of reaction that is called displacement reaction. As the name suggests, displace means the more reactive element will displace the less reactive element from its compound. This type of reaction is known as displacement reaction. That is the reaction in which a more reactive element displaces less reactive element from a compound. Now, generally this type of reaction takes place in solution state because the particles are required to move and take part in the chemical reaction. Now, suppose we take some examples. Like suppose in first, suppose we add iron nail to copper sulfate solution. This will be blue solution. Now, if we'll see here the metal activity series, again potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, mercury, silver, gold and platinum. So this is decreasing reactivity. Now here we see that in this part we see that here is the iron and here is the we have left one copper. So this is copper. So iron is above copper in the activity series, means iron is more reactive than copper, so it displaces copper forming FeSO4 and copper is displaced. So the color of the solution will change to green and here reddish brown metal is deposited. Reddish brown metal deposits. So suppose we take this reaction here as an experiment. We take CuSO4 solution which is blue in color and some iron nails are placed. Iron nails. Now after some times we observe gradually that the blue color of solution gradually changes to green and reddish brown metal gets deposited over the nails. So this is due to the displacement reaction. Now suppose we take another type of reaction for the similar type of process. Suppose this time we take zinc granule is added again to copper sulfate solution which is blue in color. Then it forms ZnSO4 plus Cu. Now this time it will be colorless solution. So both of them are due to the displacement reaction. Now take another example. That is, in these two reactions the metal is used to displace the less reactive metal, but this time we are using another type. Suppose this is potassium iodide. This is colorless solution. Now when chlorine gas is passed through it, which is greenish yellow colored acidic gas, then chlorine is more reactive than iodine, because if we write for halogens in nonmetal, then fluorine, chlorine, bromine, iodine. So chlorine is above iodine, if it is more reactive, it displaces to form this type of product. Now due to this one, it turns yellowish brown, or sometimes we write here purple or violet is also word used. So the solution will turn purple or violet. So this is due to the displacement reaction. Now take some more example. Suppose we take another example, that is which in general we perform the reaction in a laboratory, that is action of acid on action of dilute acid on metal. So if the active metals react with dilute acids, like suppose we take Zn plus dilute H2SO4 or dilute HCl, that is the metals above hydrogen are more reactive than it. So the metals above hydrogen can displace hydrogen from the compound. As a result, when it is displaced, it forms ZnSO4 plus H2, hydrogen gas is evolved. Similarly, if we take hydrochloric acid, then zinc chloride plus H2 is evolved. So this is also a displacement reaction. Now take another one. Action of water on metal, again active metal. Now here in this part of reactions we students see, suppose in this part, up to this part, since the displacement reaction takes place but the product formed again dissolves in water. So below that, suppose we take from magnesium to iron. Suppose the water required here is either boiling or steam, boiling water. It gives us boiling or steam. It gives us this type of product. So in these reactions again we see that hydrogen gas is displaced. So in all these displacement reactions, students, we see that a more reactive element displaces less reactive element from their respective compounds. As a result, the different types of products are formed. Now, the next type of reaction is double decomposition. Double decomposition or displacement reaction. Displacement reaction. Now here students, we see in this reaction that two substances decompose and exchange their ions. That is the reaction in which two compounds exchange their ions to form two new products. Now here student, we see that decomposition or double displacement reaction takes place in aqueous solution state, because the ions, the particles are required to move freely such that they can exchange their positions, exchange their combination or place. So this generally takes place or usually takes place in aqueous solution state. So it takes place in, or we will write it later on. Now, the double decomposition reaction may be of two types. First, neutralization. As we know, neutralization is the reaction in which acid and bases react to form salt and water. So, acid and bases react to form salt and water. So neutralization reaction is a special type of double decomposition reaction. Like you see, suppose we write NaOH plus HCl. Now the ions are exchanged. As a result, it gives us NaCl plus H2O. Now all types of neutralization reaction, whether suppose we take another one, suppose we take KOH plus HNO3, it gives KNO3 plus H2O. Now here, student, again we see, suppose whatever may be the type of neutralization reaction, what is a common feature of it? Suppose we take first example, NaOH plus HCl gives NaCl plus H2O. Now just we have written exchange their ions. So in this solution it has these ions, Na plus and OH minus ion. Here this type of ion, H plus and Cl minus ions. In this part, this is the Na plus and Cl minus ion. H2O is the covalent compound product, so it will not be ionized. Here, if we cancel these ions, common ions on both the sides, then what will we have left? Here, OH minus ion from the base and H plus ion from an acid to give H2O. So whatever may be the type of neutralization reaction, this is the common reaction. Means we can say that neutralization is especially reaction between hydroxide ion derived from a base, H plus ion derived from an acid to form water molecule. So all neutralization reactions are double displacement or double decomposition reactions. Clear, student? Now here, student, we see that when neutralization takes place, acid and bases react to form salt and water. But sometimes that is opposite to the neutralization. When a salt dissolves in water, then they react to form acid and bases. That is, the solution, salt solution will be acidic or basic depending upon the strength of acid or base used. And then this is especially known as hydrolysis. That is the reaction of a salt with water to form a solution which is either acidic or alkaline. But question is asked, what type of salt will undergo hydrolysis? If the salt is made from a strong acid, like you see, a salt made from a strong acid and a weak base, weak alkali, form acidic solution. And a salt made from a strong alkali and weak acid will form a alkaline solution or basic solution, and accordingly they will affect the litmus paper. Like this one will turn blue litmus red and this one will turn red litmus blue. Like example we take FeSO4. If it is dissolved in water, it gives FeOH whole twice plus H2SO4. Now we see that it is a strong acid, it is weak base, so the solution will be acidic in nature. acidic solution. So similarly, this is the type of double decomposition reaction. Exchange of ions take place. Now, the next type of double decomposition reaction, which is especially known as precipitation reaction. Precipitation reaction. So, as we know that if the reaction between two solutions take place and one of the product is insoluble, the insoluble product is called precipitate and the reaction is called precipitation. So, the reaction between two substances in solution to produce one of the insoluble product, that is called precipitate. Precipitate is called precipitation reaction. Now, just we have written that is it is in solution state. So precipitation reaction is always taking place in aqueous solution. In dry state it will not take place. This is why if we take an insoluble reactant, then the insoluble product formed will form a crust over it and reaction will stop. So now there are many examples of precipitation reactions. Like you see, suppose we take sodium sulfate solution and barium chloride solution is added to it. Then here double decomposition reaction takes place. Ion is exchanged. Now this is NaCl. It will be in the form of solution. And the next product is BaSO4. That is the white precipitate. So this is also used in practical for the test of sulfate ion. So this is again the observation. Second, suppose we take another example. Suppose we take lead nitrate solution and NaCl or HCl, means any chloride, salt or acid is used here. Double decomposition reaction takes place. Here it is PbCl2, white precipitate, plus in this first part, that is according to it, NaNO3 is formed. So this is white precipitate insoluble in cold water, but soluble in hot water. This is the characteristics of lead chloride, that is it is insoluble in cold water but soluble in hot water. Now take some more example of precipitation reaction. Now we see here, suppose we take silver nitrate solution. This reagent is used for the test of chloride ion, chloride radical, and we add NaCl or HCl acid. As a result, it gives AgCl plus this one NaNO3, or according to this it will be HNO3. Now what is characteristics of it? White precipitate soluble in excess of NH4OH. So this is the another type of precipitation reaction. Now take one more example. Sometimes when alkali is added to a salt solution, then The metal hydroxide precipitates with characteristic observation that is used in practical. Like you see, suppose we have CuSO4, that is blue solution, plus NaOH. It gives CuOH whole twice plus Na2SO4, that is pale blue precipitate. Pale blue precipitate is formed, which is insoluble in excess of NaOH. So, students, we have discussed some of the examples of precipitation reaction and the other types of reaction. Clear? So, we have completed the different types of chemical reactions, and the next remaining part will be studied in the later topics. Okay.